Hey everyone, welcome to another edition of Chemistry Online. Today we're going to be talking about something called scientific notation. Now, chances are someone who was not me at some point in time has taught you what scientific notation is. So if this is review, sorry about it. If it's not review, cool, this is something new. Okay, so here's what scientific notation is. It makes really, really big numbers or really, really small numbers easy to read. Now, to be clear, when we're talking about scientific notation, all of these numbers are going to be greater than zero that we're talking about. So, for example, this number is 98 billion. And then the other number is like 0.0000000089, for example. Big numbers, numbers about things that are really, really big, like the distance in miles from one planet to another, or something that's really, really small, like the distance separating an atom from another atom. That's kind of why in science we would use scientific notation, is because a lot of things we talk about are really, really big or they're really, really small. So that's its purpose. And this is going to come up. There are going to be a couple numbers that we're going to be using a lot, especially next semester, that are in scientific notation. So just kind of be aware of that as we move forward here. For a number like 98 billion, this is, we could write this as 9.8 times 10 to the 10th, or we could write it as 9.8 times 10 caret sign 10. This second way of writing it is most often how it'll show up in your calculator, or at least it used to show up like that. You'll find this caret button on your calculator. Sometimes now it'll just put it as a little superscript. It'll put it as a little exponent there, but not always. It kind of depends on what calculator you're working with. And then a really, really small number, like here, where it's got, these 10 zeros, it'll be something like 8.9 times 10 to the negative 10th, or 8.9 times 10 caret negative 10. Again, two different ways of looking at this. It's the same number written in scientific notation, just a couple different ways of expressing it, just kind of based on what you're using. I'll tend to express it with the caret just because when I'm typing it out, it's a little bit easier to do it that way. Also, it's much clearer if the negative is there. Sometimes when you have it as a superscript or an exponent, the negative becomes really, really small, and it's almost more difficult to see that way. So just know either of these is correct. Okay. Couple things to know. Just this is general math stuff. So hopefully some math teacher at some point in time has taught you this. Did you know that if you take the decimal, like let's say between the 9 and the 8 here, and you move it to the left, as you move it to the left, wait, that's wrong. As you move the decimal this way, that's to the right, the exponent increases, it becomes more positive. Oh, you know what? We're talking about a number like 98000.0. Actually, let's just do it like this. 1, 2, 3, 4.5678. Oh my gosh. Sorry about this, folks. Okay, so if you have a number like 1234.5678, as you move that decimal to the left, you're going to increase the exponent. So for right now, it's 0, but as you move it to the left, that starts to become like a 1, a 2, or a 3. As you move the decimal to the right here, your exponent is going to decrease. So it'll become like a -1, a -2, or a -3. This is kind of just a convoluted way of saying that big numbers have positive exponents and small numbers have negative exponents. Moving forward here. Sorry about that waste of the past minute. Okay, scientific notation is always a single number. So for example, in red here, you'll see that I just have a 3. I could have a number like 1, 2, 3, 4, 5, 6, 7, 8, or 9. I could not have a number like 10 or anything above that, because if I had 10, then it would be 2 digits. You can only have 1 digit kind of in front of the decimal. And then after the dot, you can have as many numbers after the decimal as you want. So here I have 4 and 5. You could have 4, 5, 6. You could have 4, 5, 6, 7. You could just have 4. Or you could even just have no numbers at the end. It could just be 3 times 10 to the fifth. That would work. You'll always then put times 10. That purple thing is always constant. And then at the end, you'll put an exponent. This exponent, again, it could be any number. It could be 1, 2, 15, 17, 25. It could be a negative number too. It could be -5, -3, -2, whatever you want. But this is just kind of the formula or the format that we express numbers in scientific notation. The biggest mistake people will do here is they'll write something like 34.5 times 10 to the negative fifth. That would be incorrect just because, again, we can only have one number in front of the decimal. And that's just how we do things. So sorry about it. Again, small numbers have negative decimals. So that would be like a number less than 1. And large numbers have positive decimals or positive exponents. Sorry. Negative exponents, small numbers, positive exponents, big numbers. Okay. The following game is called Is This Number in Scientific Notation? The answer for 2 of them is no. The answer for 1 of them is yes. It's up to you to decide which one. Hopefully you were able to figure out that it is the first one that is actually in scientific notation and the other 2 are not. Good work. Okay. For this next one, just tell me, is the number big or is the number small? Rephrase that. For the first 2, tell me, is this exponent going to be positive or is it going to be negative? For 3 and 4, tell me, is the number going to be big or is the number going to be small? So for the first one, this number is going to have a positive exponent just because it's a number greater than 1. For the second one, it's a number less than 1, so it's going to have a negative exponent. Notice that in both these cases, they have an exponent of 7. That's because here in this first one, you'd have to move the decimal point over 7 times. In the second one, you'd have to move it over 3, 6, 7 times again. So something that I was trying to explain earlier is about how when you move the exponent a certain way, it either becomes positive or negative. We get the exponent numbers here from how many times over we move the decimal. For 3 and 4, 3 is going to be a small number and 4 is going to be a big number. To get this -2, we're going to have to move it to the left, or sorry, that's how it looks on camera. This is me pointing to the right. This is your left. So it would become 0.03051. I'll always put a 0 in front of the decimal just because it looks cleaner that way, I think. I don't know, easier to see the decimal. And then for here, when you put a 10 to the 12, you're going to end up with a number that has 10 zeros. So we got 3, 6, 9, and then 10 zeros. Kind of cool. To figure this out, you just take the decimal and then move it to the left. Yeah, left 10 times, or 12 times, sorry. And then you'd end up with 10 zeros. Common misconception here that a lot of people will think is they'll think, oh, this is 2.8 times 10 to the 7. That means I just throw on 7 zeros. It doesn't usually work that way. Very rarely, if ever, will it work that way. Or, oh, it's -7. I just add 7 zeros in front of the 4. Again, doesn't usually work. Okay, here are 5 questions. Let's take a little time here together to practice the first 2, and then the other 3 you guys can do on your own. So for question number 5 here, we're going to have to convert this into scientific notation. So I'm going to start by moving it 3 places, and then we'll move it 4. So I get 3.45. Notice how I stopped between the 3 and the 4, just because I only want one number in front of my decimal. And then in this case, it would be times 10. And then to figure out the exponent, we moved it 3 times and then an extra 1. So we would say that that is -4. It's negative because, well, one way of thinking about it, this is a small number. Another way of thinking about it is you're moving it to the right, so that makes it small. For the second one, we're going to want to put the decimal point right there between the 1 and the 2. So we're going to have to move it 3 times, and then we'll have to move it 1, 2 more times for a total of 5. We get 1.28, and then times, in this case, it's going to be 10 to the 5th. It's a positive 5 because this is a big number, or if you want to think about it, I have to move it to the right. So anytime you move it to the right, you get a positive decimal, and I get 1.28 times 10 to the 5th. Kind of cool. You guys can feel free to try the rest of these on your own. Here are the answers, just in case you were wondering. This is all I really have to teach you guys about scientific notation, so hopefully you learned something. Let me know if you have questions. Let me know if anything pops up. Otherwise, thank you guys so much for watching, and have a great rest of your day.